Good afternoon.
Good afternoon.
Good evening. All right. Good afternoon again, guys. My grace period has ended. How are you doing tonight?
Not bad, sir.
Good,
Doing good
good,
here.
good,
Doing
good, 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 good. How has it been going? Did you do any revision? Are you ready for tonight?
Yes, sir.
Okay, let's listen. Good. Okay, good. All righty. I'm ready to go. There are one or two housekeeping matters that I need to be looking at, but I won't necessarily deal with those housekeeping matters now. I will definitely send email to the class, to those persons who I need to have a conversation with. But let me just switch this. Okay, so let me tell you now. One housekeeping that I need to deal with. We lost a staff member of ours, and at 6 o'clock, they are going to be having a, oh, hold on.
Sir, breaking up in a sir. I can barely hear what you're saying. I'm not sure if it's me alone.
Sorry, I was switching devices. Say it again. What were you saying?
I was saying I couldn't hear.
All right, because I was switching devices. I was switching the devices and not recognizing that I was still talking, so forgive me. So I'm just saying, there is a staff member, the college lost a staff member recently. So there is a little remember on something at 6 o'clock. I won't be leaving the class, but I'll be just joining from another device. So at some point in time, I may beg your pardon just to go and say a thing or two. Not sure the family members will be there, but for sure I'm expecting students and staff alike. And as team leader, I should be there. But of course, I know I have a responsibility to be in here with you. So I am here and will be here. All right. So we've been having lots of conversations about what do you call it? About limits of functions. We've been looking at lots of real life examples to help concretize the whole business of limits and functions. Last week was our first week. The baby stuff kind of finished last week. Last week was really to get you guys in a state of mind, ready for big school work. Now the time meets the road. We need to get to where it is that we need to be going. Can anybody recap what it is that we did last week in looking at the intuitive approach? Anybody, somebody? And I can use this example, I can project this example so that if you want, you can use it to do the explanation. I need for you though to speak to me because I'm moving on into something else. Let's hope that the concepts were built because I'm moving into something else. Somebody quick and fast. And if I don't get that, I'm going to call upon somebody in the class. And I'm doing this because I got a message that somebody here is here for the first time. We will have conversations about that afterwards. Let's go, let's go, let's go. Anybody, somebody.
Sir, from what I recall from last week, the intuitive approach assesses the values closest to the limit from both the left and right hand side.
Very good.
Then plugs it into the formula to assess whether or not both sides are approaching the same value. And
very good. And you don't finish it, right?
or if it does approach the same value, we say that the limit is of a good behavior. And if they don't, then the limit is of a bad behavior.
Very good. Any questions regarding that? In a nutshell, that's what it is. But what becomes difficult now is to find out what value it approaches to from both left and right-hand side. Remember the conversation we were having last class regarding the negative value. Some people were quoting some other value coming from the other side as opposed to from the side in question. Did we get an opportunity to look back at that one to see exactly where we're coming from?
Yes, sir.
Is it a little clearer to you now?
Yes, sir.
Good
Yes,
job.
sir. My mistake was not using the number line. And once I use the number line, then I realize better have it lock.
Okay, good job. Is there anybody in the class that has a difficult, outside of the person who just joined, is there anybody in the class that has a difficulty with that? I'm doing this because I'm moving. I'm moving tonight. I'm moving. Is there anyone in the class that has a difficult? Thanks, Rayton. You did pretty well. In recapping, succinctly what it is that we did. Is there any? Go ahead, please. Who is this?
I was lost in the first class, sir, but after time, I kind of get.
Sorry, Alan, you're low. You're lost in the first class with what, Pops?
But I got a better understanding in the other classes after that.
Okay. The examples helped you, right?
Yes, sir.
All right, good job. All right. Okay, Thais, no problem. All right, yeah. So so I will use, guys, everything possible. Manipulatives, at point in time, you'll hear me say, put up your right hand or put up your left hand, and I want to do this, I want to do that, so that I can use it to concretize your understanding. The aim of this game is to get you to really understand and appreciate the mathematics. You will be surprised to know the conversations that I've been having with some of your classmates, some students who would have left school not last year, but many years ago, and are now coming back into this whole school system. Not everybody's at the same page. And in order to get everybody to be at the same page, I will have to do things to get people to be where they are supposed to be. With that said, I am moving. And I want all of you to listen to me, and listen to me carefully. Last week, I said to you, the question says, evaluate the limit as x tends to 2 of x plus 1 over x minus 1. And last week I said to you that at no point in time did I substitute 2 into the function. What I did was to substitute things very close to 2. And if you look at the left-hand side, LHS, you can see where I moved to 1.9, 1.99, 1.999, 1.9. And from the right-hand side, I went to 2.1. Then I tried getting a little closer, 2.01, 2.001, 2.0001. And I looked at the behavior of the limits, the behavior of the limit. And I recognized that coming from the left-hand side and the right-hand side, the limit is the same. Alan said that he found the example living at 1 yard, number 10, for argument's sake, or number 2. And if he approaches his house from the left-hand side, or from the right-hand side, or if he approaches his house from the top of the road to the bottom of the road, he still gets to that house. All right? Hear me tonight now. What we did last week was the intuitive approach. That approach is very important, but here goes another approach. This approach is going to be the calculations or the algebraic approach. The calculation or the algebraic approach. Before you start bombarding me, the recordings come in, you see. I need, let me just straight out there, and then somebody who think they understand what I'm talking about can talk to me afterwards. The recording comes in. Normally, I was able to just use my phone and share the recording to my YouTube channel. The interface now, I don't, it has changed, and it's saying that I can't do that. So there is only one Dege device that I can use, which is almost inoperable now. So I'm just saying that to you. I want to send the recordings. I have 2 recordings to send for you. One for Tuesday and one for Thursday of last week. They're in my emails. Anybody who really understands what I just talked about, you can meet me after class, or we can stay after class and we can, go through it. So I can, again, start using my cell phone. So I can just slide the stuff into my channel so we can get the stuff. All right, let's go. So we're using the calculations approach. And for the calculations approach, I would love for you to assume that x is going to be equals to 2. What am I asking you to do?
Assume that
Assume.
x is equal to 2.
I'm asking you to assume that x. Last week, did we assume that x equals 2?
No, sir.
What
No,
did we
no,
do
sir.
last week?
Wait,
Find
Numbers
if it
that were
approaches.
close
try to
to
find
2.
the
Very good. We look to see what number or numbers getting very close to the number. This week, we are going to assume that the number is 2. Watch me. So we are assuming that x equals 2. So therefore, the limit as x tends to 2, because we're assuming that is equals to 2, anywhere in the function I see x, I put 2. Anywhere in the function I see x, I put 2. What is 2 plus 1?
That's
3,
3,
sir.
sir. 2 plus 1
is
is
2?
3.
What is 2 minus 1?
1,
What is 3 divided by 1?
3.
3.
All right. So my answer is 3. So I can see there, in a quick and fast way, that I got the same answer as before. By assuming, remember, the limit is not 2. The mere fact that you see this sign, the arrow, it means that it's approaching. It's not equals to 2, it is approaching 2. But for ease of calculation, we are going to assume that x is equals to 2. That is going to be my calculation or my algebraic approach. Just assume that the function, that the limit that the function is approaching, it is equal to that number. And anywhere in the function, the given function, I see the variable. Now I say x tends to 2, but the function don't have to be in x. I could say the limit as p tends to 2 of p plus 1 over p minus 1. So whatever the variable is, we are going to substitute that value into the function, and we should get our answer. Now, let me just go up top and have a conversation with you as well. So last time we looked at x approaching 1. So we are going to let x be equals to 1. So the limit as x tends to 1 of 1 plus 1. What is 1 plus 1?
That's
2,
2, sir.
sir.
2. Let us check to see if our answer was 2. Yes, the answer was 2. Question.
Not yet, sir. Still trying to figure out why I use the intuitive approach.
Sorry, say it again, Papa.
Yeah, I hear what I'm saying. It's a much easier way to do it.
Oh, yeah. There are different concepts in it. There are different concepts. So the method that we learned before, you're not going to throw it out. I'm going to show you where that method is going to come. And I'm hoping that I can even touch a piece of that method in another form tonight. So this is much easier. I could have come to class and I could have started with this last week. But if I started with this last week, I would have had problems. Go Burrell.
Oh, so I was asking, all right, so seeing that we are assuming that x is 2 in this case, are you going to have instances where the assumption that x equals 2 will be incorrect?
No,
Okay.
not at this level. So So I want you to be very vigilant to what it is that we're doing. If the question says to use the intuitive approach, you're not going to use this method. You're not going to use this method. If the question says to use the calculations approach, you're not going to use the intuitive approach. If the question don't tell you which approach to use the calculations approach or the algebraic approach. If there's no specificity to what to use, you say this method that I'm teaching you now, this is the method you're going to be using. Sir, why? Because as you can see, it's 2 lines and you get the answer, as opposed to be doing from the left-hand side, from the right-hand side. Then, sir, why he taught us that? Because there is good sense in teaching, because you're going to be using this in another format a little later on. Question, go Kenneth.
Yes, sir. What if I get x tends to infinity?
All right, hold that question for me, please. All right, so I'm going to give you a few questions here. All right, let me use this one. Hector, go ahead, please.
All right, sir, before you move on, sir, can you just, because I was switching devices, sir, I'm not asking you, sir, to just do a brief run over other what you just did for me, please, and thank you.
All I did was to
No problem, sir.
all I did was to introduce the calculations approach. And the calculations approach was to look at the function, given here. And then what it is that I'm seeing is anywhere the function is the limit is approaching, I'm going to assume that the limit is that number instead of investigating from the left and the right. I'm going to assume that the limit is that number itself. And anywhere in the function I see the variable, I'm going to substitute the limit. Got that?
Yes, sir.
Yeah, man. That's all that we did. And that's all that is going to be required, really. Okay. Our question was asked, what if it is infinity? What do you think we can do, guys, if it's infinity?
Pick a number, sir.
Pick a number. What kind of number you can pick?
Any positive number, sir?
Any positive number, such as
Integer.
An even number.
an even number. An even number.
So
An even number?
by example, I say something already, you know.
What is seen?
I say where you have to work out the left-hand side and the right-hand side when the infinity symbol is given for the calculations.
Yeah, that's for the intuitive approach, though, listen. For the calculations approach, I don't have to do that.
You don't have okay.
Yeah. But tell me now, somebody asks, what about the infinity? What number would I substitute inside here? Listen to me, no man. When you talk to me, no man. Hey, my class can't daddy, you know, man. And when I ask this and nobody now answer, just
Sir, answer a couple times now.
say it again.
Somebody said 10.
I didn't hear 10, I heard 3.
No,
Yeah, but 10
sir.
will equal to 2. So I would say 10.
Would it matter which number we select, sir?
It does in this case. If we're using a calculations approach, it does matter.
Sure, it's a large enough number.
Which is?
1 trillion.
I wouldn't go as far as a trillion. Put in a million and tell me what you get.
Oh, you want us to do the working out, sir?
Yes, sir.
All right. So I
Said
got
one, sir.
1.00000005.
Which is
Is, me,
which is
sir.
what value? Which is what value?
One.
One,
One.
sir.
Good. And the limit did approach 1. Can you see that?
Yes,
The
sir.
limit did approach 1 right here.
Just do a
Yes, sir.
calculation a while ago, sir. So I'm gonna use
Sir, which
200. I'm gonna use 200. I'm gonna get the same one. So does it matter what
You just
value?
need yeah,
infinity?
an infinitely large number is just an infinitely large number. So it worked for 200. It could also work for 2,000. Could also work for 20,000, 200,000, 2 million. Yeah. So I just selected a large enough number. I was just saying to whoever said a trillion that I don't have to go that far. I could really go to a million and you can see exactly what is happening. However, I'm going to be teaching a new concept tonight that when we see the infinity, positive infinity and negative infinity, we're not going to just randomly substitute a value. There's going to be a specific method that I'm going to show you. So what I showed you just now was just a quick shot to say to you that the limit still goes to 1. I'm going to do this question another way, which is how I want you to do it. And let me pause and repeat myself right here. Because anybody who gives me this on a test is going to get 0. I only did this quickly using the algebraic approach. The method is not incorrect because I'm using the algebraic approach. But normally, when we get a question going to infinity, positive infinity or negative infinity, there is a particular method that we would use. All right? Okay, moving on. Any questions? Moving on. So I have 4 questions here that I also have the answers for. Questions are in black, my answers are in red. I want you to quickly just run through these questions. You don't even have to write it. I just want you to do the substitution of your own and tell me if it is that you agree with me. Particularly so because you guys need to know how to use your calculators, and I want to make sure that you're in a good stead in getting this thing done properly.
Sir.
Quick and fast.
Quick one, sir. Sir.
Yeah, man, I'm here, man. I'm just trying. I just was trying to unmute. Come on here, man. Go ahead.
See, I have your answer in already, sir, right? And you have
Yeah, man.
6/25.
Mhm.
Is there any further calculation to that?
No, can't go down any more further. I can't break that down any further. There's nothing common between 6 and 25. Is there? I should ask.
No, sir. Even
All
number
right. So I just leave it at that.
Sir, for number 3, I'm getting a +2. That is not -4, right, sir?
Yes,
X
please.
to the limit of -4.
Mhm.
Sir?
Putting it
I'm
up
hearing you.
Oh, I'm saying is that at question 3, X is closer to -4, right?
Yeah, man.
But
Yeah. Yeah, man.
So my answer is positive 2.
How did you get
Not-
that though?
Negative 4 square divided by negative 4 minus 4. I forget what I'm saying. Let me break it.
Talk to me no more. You're talking, not stopping. Talk, man.
I'm saying that I got positive 2.
And you were working the question with me. You said negative 4 squares over negative 4 minus 4. So what's the next line? I'm waiting on you.
Huh? What do you mean? I'm saying I'm going to break it down instead of putting everything in one.
No, man. What is wrong with you tonight?
But sir,
Everything that you have is correct, you know. Hold on. Everything that you said to me just now is correct, you know. What is your next line?
What do you mean my next line? You mean question 4?
Hello.
Oh, sir, I see our calculations as well, and I don't know if me do it wrong, but I get positive 2 as well, sir.
So I think what you
I know
guys,
exactly what you guys doing. I know exactly what you guys doing now. So that's why I want you to work it out. So tell me what it is that you did.
yeah, I know what they're doing wrong as well. Or
Sir,
That's why I'm breaking it up.
Go ahead for me, please.
all right,
Hello.
if I may. So
sir,
what you're
probably
doing, guys? All right, for question 3, that you guys have maybe have an issue with. So what we're looking at there is naturally. So
Sorry to interrupt, but I'm not hearing it clearly at all. Can you start over, please?
you're referring to me? Thank you. All right.
Yes,
Yeah,
not
how do
hearing
you
it
get
clearly.
negative 2?
Negative 2. All right. So what
Yeah.
we're looking at in this case, where I don't know if substitution is the right word, but that's what I'm doing essentially. Substituting minus 4 with x. So for the first bit of it, you have x squared.
Square.
So minus
Yeah,
4
which
squared.
is
So naturally you're gonna get a positive 16 in this case. So for the
Press pause, Tajay.
what?
Press pause.
Is negative 16 or positive 16?
No, it's not. It's not negative 16. And that's what I'm
Negative.
saying to you. I know exactly what the problem is. Because you're all putting in your calculators negative 4 squares, and it is going out to be negative 16. Because when you put in your calculator, and that's why I was asking you what's next, because this is what I want you to hear you say. So the limit as x tends to 4, negative 4 that is, of x squared over x minus 4, what it is that you're doing is to say negative 4 squared over negative 4 minus 4. And your calculator is giving you this as negative 16, which is incorrect. When you put negative 4 squared in your calculator, the calculator, and that's why I said I don't want you to get a kenko, the calculator is using negative 4 and square it to give 16 and maintaining this negative sign, so it's giving you negative 16. That is incorrect. When you square a negative number,
Sir?
you're actually getting a positive number.
Sir?
Uh-huh.
I got a positive 16 when I do that, sir. I put 4 negative and then press a square sign and I got positive 16.
What calculator are you using?
Sharp.
So, sir, the negative supposed to be outside of the bracket.
So, no, ma'am. Look at how I have it. So whenever you're raising a negative number, what you need to do is to put it into parentheses, please. Okay. So go ahead and do that calculation for me now. Open your parentheses. Open your parentheses. Put your negative 4, close it, put your square, and do the stuff and tell me what you get for the answer now.
Okay, positive 16.
Absolutely. Some calculators are built in for syntax construction, sentence construction, we call it in English language, and the other calculators aren't. So if I put in my calculator -4 squares without the bracket, it will give me the correct answer because my calculator is advanced. So I say to students, whenever you are squaring a negative number, put it in parentheses. Always put your negative numbers into parentheses. And BOMDA says you work your brackets first. So here's my question to you now. Are you all now okay with number 3?
Yes, sir. I get the negative too.
Yes, sir.
Yes, sir.
All right, good job. Numero 4. Number 4.
I got the answer as well, sir.
Good job. You believe me now when I tell you that I'm going to be very deliberate in you using taking a calculator and using a calculator in my class? It is for reasons such as this. Far too long, I am teaching topics and you're getting the questions wrong, not because your method is not right, but because you don't know how to use your calculator. So
Well,
make sure.
I don't want to use it for number 4, sir.
It depends on what calculator are you using, sir?
A Casio FX82 MS.
All right. Follow my algorithm, please. Open your
Sure.
parentheses.
Sir, I'm talking about number 4 now, sir, not number 3.
Sir, I cancel
No, hold
the
on.
negative.
No. Hold on, guys. I'm speaking, so you have to wait until I'm finished. Hold on. I'm giving an instruction. So I'm saying follow my algorithm, please. Open your parentheses. Then you're going to press -1.
Sir, repeat that.
Open your parentheses on your calculator.
Yes, sir. Yeah. Yes, sir.
Press -1.
Yes, sir.
Another -1.
Yes, sir.
Close the parentheses.
Yes, sir.
Look at your calculator to the left. You're going to see an ABC button. Can you identify the ABC button?
Yes, sir.
Press that for me, please. You're supposed to see a back way L come up or a front way little L. Just a little symbol.
I did that.
Good. Then you can open other parentheses.
Yes, sir.
-1.
Yes, sir.
-2.
Yes, sir.
Close the parentheses.
Yes, sir.
Equal. And you should see 2 with that same little funny symbol and a 3.
Yes, sir. I find it out.
Good. So that
Yes,
little
sir, why
funny
you have
symbol
this
is
here?
a division. Huh?
So why you have a -2 over -3 working out right here?
Because that's what it is.
Oh, so
Look.
you just break it. Oh, okay, I understand. I
Yeah,
understand.
I am substituting -1 here.
Okay,
So see
I
the
understand.
-1 that I'm right. So -1 minus 1 is a -2. So this is what it is. I mean, I
Yes,
divide
sir.
two negative numbers, I get a
All
positive
right.
number. All right, good. So are we okay with what is happening here now?
Yes.
Is there anyone in the class that is not seeing what is happening?
Yes, sir.
More and more calculation, more and more calculator practice, sir.
Okay, so far, sir.
Okay, thank you. All right, no problem. I hear you, Mason. All right, so I am going to be moving into another form. So this is my calculations method. My algebraic approach, my calculations method, it's done. I'm not spending 1 more minute on it. What I did the questions and give you the answers. But you had to work to see to it that you got the same answers as I did. Now I'm moving into the indeterminate form. Indeterminate form. What do you think I mean by something being indeterminate?
Not sure. Inconclusive.
Not sure, inconclusive. I like that definition. Anybody else has anything?
Undetermined.
It's undetermined. Okay. Very good, Alan. Undetermined. Okay. Anybody else? I need 2 more.
Cannot be defined.
I'm not hearing that. Say it again.
Cannot be defined.
But it's an indecisive already.
Yeah, indecisive is one, but who oh Lord. Say that one. Somebody was saying something. I didn't. Wasn't so clear. What was that you saying?
I said it cannot be defined.
Or cannot be defined. Okay. Yeah, for talk up in a papa. Cannot be defined. All right. I'm gonna come back with that one. I'm gonna come back with that one. One more. I'm going to start calling upon students to answer me now because when I give you the opportunity to answer, they don't talk to me.
I will take my chances. Unknown one.
It's an unknown what?
Unknown.
Unknown. All right. Okay. Unknown. Okay. All right. So here's my example to this now. And I want you to understand what is happening here. I want you to be able to relate my example to what is taking place here because it will help you later on. Tell me the difference. Tell me what is happening when I go on social media and put on a filter on my something. Don't even know if it's camera or what. I put on a filter. What will you see?
A catfish.
Say it again.
Mask.
A catfish.
It's a mask. I like that word. I put it on a mask. What else?
A disguise.
It's a disguise. Give me another one, another adjective. We're getting very nice.
A facade, sir.
It's a facade. So when I remove that facade, what happens?
Real you sure.
And guess what will happen? Nobody not going to want to follow me again because they're going to say I'm ugly. All right? Hold that thought. That's exactly what the indeterminate form is talking about. All right? Coming back to that example, I love the term, the facade, disguise. Love it. Watch it now. So in a question such as this, we need to apply the algebraic approach because in doing this question, the indeterminate form, we need to see exactly what is happening. So what I'm going to ask you to do for me now is to use the algebraic approach and tell me what answer you get. Use the algebraic approach and tell me what answer you get. I'm going to log on to this thing to see if, just to register my presence here.
Zero over zero, sir.
0 over 0. What is that though? Talk to me. When it says 0 over 0, what does it tell me?
It has no value, sir.
Undetermined.
It has no value, undetermined. So do you think that's the final answer? Talk to me now.
Sir, I didn't hear that,
Yes,
sir.
I'm saying, do you think that's the final answer?
No,
Zero?
sir, but not sure.
Somebody that
Sir,
says 0.
so what asking, sir? I said 0 is the final answer.
No, but you just said 0. Is 0 the final answer though?
Oh, I guess 0 so far. I'm not sure if 0 is the final answer.
No, but what did you
I
get?
guess 0. 0 over 0.
Okay, there's a difference, There's
Oh,
a difference. It's 0 and 0 over 0. Okay. And I want you to all to remember this. There is a difference between 0 and 0 over 0. So whenever it says 0 over 0, it is saying to you that it is the indeterminate form. Sir, what does this say? I heard a lot of adjectives. It's a facade. It's undecisive. It cannot be determined. What it says is that there is something in this function that is preventing the true limit of the function to come out. When I put on that filter on my social media video, it shows, say, I am this type of looking person. But when that filter is off, the true me comes up. So I'm saying to you that there's something in the function preventing the true limit from coming out. And I want you to watch what is happening here on screen now. You recognize that x squared minus 5x plus 6 is factorizable?
Yes, sir.
Can you go ahead and factorize that for me, please? No, let me tell you something. Why I'm saying to you that, and I will need to speak with students of the class. And I did say to you that I have some housekeeping matters. The prerequisites for the class must be met, because there are several things that I'm going to come to class assuming that you know. This is one such thing. Teaching you factorization is not on the syllabus. Teaching you factorization is not on the syllabus. So I'm expecting you to come to class with this prior knowledge. So I'm going to give you 3 minutes to factorize for me x squared minus 5x plus 6, and then we'll have a conversation, quick and fast. Always stay. What's the answer?
Sir, x minus 3 and x minus 2.
X minus 3 and x minus 2?
Yes, sir.
Okay, I hear you. Anybody else?
The same answer, sir.
You got the same answer. Okay, thank you. Anybody else? I'm seeing that I'm going to have a problem in this class because it's just the same voices that I'm hearing, and there are students in the class who are not making an attempt to unmute and have a conversation in the class. And this is how I will know that you are participating, that you don't just log on and take away yourself from the computer or your cell phone. We're going to have a challenge.
Good evening, sir. Sorry, I'm late.
No problem. Good evening, John. Ablame, talk to me. I heard two answers. So happen that both answers were the same. X minus 2 times x minus 3. Anybody else?
Sir, I got the same thing, but is X. Yeah, basically, I got the same thing.
But what? There's something that is a little different. That's why you said, but what?
No, man, I thought you said it in reverse because I have X minus 2 and X minus 3, but I thought you said it in reverse.
Okay, what do you have? X minus 3 times x minus 2?
Yeah. Bracket X minus 2 bracket times bracket X minus 3 bracket. That's what I have.
Okay. What is 2 times 3?
What's this?
Hmm?
Sorry about that. 1 second. Repeat.
2 times 3 is?
2 times 3.
What's it, sir?
6.
Yeah. What is 3 times 2?
3 times 2.
The same thing, sir.
Same thing. So Matthew, is it Matthew? I don't know. Matthew? Who is Alan?
Yeah.
Right.
Yeah,
So
Alice.
yeah, I have to look at the screen because I'm not able to differentiate the voices yet. So okay. So I have to look to see who is talking to me now. So yes. 2 times 3 is 6 and 3 times 2 is 6. So it really doesn't matter how it is that which of the factors we write first, it still works out to be the same thing. It still works out to be the same thing.
Oh, okay.
All right? Yeah, man. Cool. Anybody else?
Sir,
Yes, please.
a bit rusty.
Okay.
I don't remember how to factorize.
No problem.
I'm trying to work it out, but I'm not getting back the -5 or -6 or the +9 and the 15 and then something. I don't know.
All right. And that's what I really appreciate. You unmuting as a voice or hit the plan. It's been a while and I don't understand it. That's not to say anything at all. So no problem. All right. So I'm going to show you the method of how it is that we do this stuff. Look at that and tell me if it rings a bell. So I'm nice to you. Read the method. Tell me if you understand the method. And we can have further conversations from there.
Sir, so this is basically explaining how you would get the function to extract the common factors.
Very good. Mm-hmm. So wait, I might just sit down for the rest of the class, waiting for you to say something to me, guys.
No.
Okay, so what next? What are you going to say to me? Are you understanding what is happening? Talk to me.
Yes, I'm starting to understand it, but I was writing it down so it can stick in my head. That is how I learn. I have to write it down then in my head.
Sir, can you give another one, please?
Say that again?
So she's asking if you can give us another one.
one.
I can't, because I don't finish the question yet. I don't finish the question yet. I'm just waiting for people to tell me that they're understanding how we end up with the factors. So I can finish this question to give you one to try on your own. How we stay?
I understand, sir.
Thank you, Ashan. T.
Get in there, sir. Get in there.
Trying to understand it, sir. Just need to see the application into the form.
All right. So what it is that we're doing, the methodology is you're multiplying the coefficient of x squared. The coefficient of x squared is the number in front of x squared. You're multiplying that by the constant term. The constant term is that term without an x variable in this particular example. So when I speak of coefficient, coefficient is the number in front of. Coefficient is a number in front of. The coefficient of x squared is a number in front of x squared. So what is going to happen? Hold on. So I'm multiplying the coefficient of x squared by the constant. And the coefficient of x squared is a number in front of x squared. And what number is in front of x squared? Can you see it?
6.
I said x squared. It's 1.
Mm.
So the number in front of x squared is 1. Can you agree with me that there's an imaginary 1 there?
Yes, sir. Yes, sir.
Yes. Okay. And you multiply that 1 by the 6 to give you 6. I need two numbers. When multiplied together gives me 6. but when added, it gives me that middle number. I need two numbers. When multiplied together, gives 6. But when I add them, I'm going to get -5, the middle number, the coefficient of x. What two numbers can we think of?
So there's
3 and 2.
3 and 2.
No, ma'am.
Negative
-2,
-3.
-2 and -3. It makes a difference if you say 2 versus -2 or 3 versus -3. Big difference. So the factors are -2 and -3. So the factors are -2 and -3. So therefore, when we multiply -2 by -3, it's going to give us +6. And when we multiply, and when we add -2 to -3, we're going to get -5. So what we're doing now is breaking up my -5x into -3x and -2x. Them something here. Then I'm going to group. Hear me out. What is common between this? Sorry. I'm putting two of these things in one bracket. So you see what I'm doing here? I'm putting a bracket here and a bracket here. Hold on.
Good evening. Good evening, Ms. Burnett. Burnett and everyone, Dr. Greg, Mr. Shani. Oh, good evening, Shan. All right, we would have wanted to keep this Margaret.
Forgive me, please, guys.
But until she's on. On? Yeah, she said she's on. All right, Mrs. Marie, you can go ahead. Okay. My apologies for not turning on my camera just yet. But let me say good evening to our dean, our school, and everyone who is on. We are here. It's not a time that we, want to.
Sorry about that, guys. They were calling upon me, but I couldn't unmute to talk because I just sent a message, so forgive me. Is the sound bothering you? Are you hearing it overly loud?
It's okay.
Okay, all right, good. Sorry about that. I'm sure at some point in time they're gonna call upon me to say something. Forgive me, guys. Oh crap. Sorry, hold on.
And so we take the time this evening to be thankful, to give God thanks for the life he lived and his contribution to our community.
All right. So what we're going to be doing is putting your parentheses here because I'm. Hold on. Okay. So I'm gonna put parentheses. Put it this way, and I want you to understand this. Forgive me, but I really want you to understand what is happening. If I have an apple, a banana, an orange, an apple, a banana, and an orange, and I want to create, watch me, an apple, no, call this an orange, an apple, and a banana. But I have 3 fruits, but I want to have 4 terms. This apple, they didn't tell me what apple it is. So the apple that I have, I can break that apple up into an OTET or an American apple. Can you follow what I'm saying right there?
So your screen is moving slow.
Hello? Somebody? Can you follow what I'm saying there? Oh, my screen is moving slow, so forgive me. Oh, maybe my internet is... Oh, it's
Yes, sir.
unstable. Are you still hearing me?
Yes, sir.
Yes, sir.
Or because the other device with the meeting is searching. Yes, Ashanti. Oh, Lord. Are you still hearing me, guys?
Yes, sir.
Yes, sir.
All right,
Yes, sir.
good. All right. All right. Sorry about that.
We're hearing you.
Yeah, yeah. It's just that I'm I'm being distracted by the other device because it's going around in circles. I thought this one had gone also. All right. So I have an orange, an apple, and a banana, but I want 4 terms. But because a banana is really a banana and an orange is really an orange, I have many different types of apples. True or false?
True.
True, sir.
Good. So what I'm trying to do now is to put an orange and an apple together, and then put an apple and a banana together. So it's the same apple. You see that is something variable with x. I mean, coefficient and a variable x, coefficient and a variable x. So I'm splitting this negative 5x into 2. When I split that negative 5x into 2, I'm going to get 2 terms. I'm going to get 2 terms. And those 2 terms now will facilitate me having 2 sets of parentheses, like here. However, one has to be very careful, very mindful that once you have a negative sign here, so that this negative sign now governs everything inside the parentheses. Remember earlier on I told you today that whenever you're doing your calculation and you have something with a negative sign, you have to put those negative signs in parentheses. Anybody remember that?
Yes, sir.
Good.
Yes, sir.
So because of this negative sign right here, so I have to put it in parentheses. But look at what happens when it's in parentheses. This negative sign is now governing every single thing in the parentheses here. It's now governing everything. So when I multiply this negative 1, and there's an imaginary 1 behind this, negative 1 times 2x gives me what?
Negative 2x.
Very good. See the negative 2x up here, so very good. Very nice. Negative 2x. And then tell me, when I multiply this negative 1 by this negative 6, what do I get?
Positive 6.
Very nice. Do you see the positive 6 up here, sir?
Yes, sir.
Yes, sir.
Good job. Good job. What's the point I'm making? You see, once the sign is a negative sign, the sign here, so can't come back right here, so it has to be flipped. Follow me?
Yes, sir.
Yes, sir.
And whatsoever sign that is in the parenthesis here is the same sign that is in the parenthesis right here. All right? So now look at what I'm asking. What is common between x squared and 3x?
X, sir.
Very good. So I'm taking out my x. Very nice. Love the sound of that, guys. X. What is left? When I take out one of the x's from here, what is left?
Just the x.
And this is the x. This is just the x here. Very good. 1x. All right. When I take out the x from here, what is left?
3.
Say it properly, no one.
Negative 3.
Minus 3.
Negative 3.
3.
Negative 3. Very good. And I have negative 3 left. And if I want to double check now to see that I'm on the right track before I move on, I say x times x is x squared, and x times negative 3 is negative 3x. All right. Boom. Moving on. What is common here? That is common there.
Negative 2.
Good job. And then now, when I multiply negative, so when I factor out negative 2 from here, I'm just going to be left with x. I'm going to be left with x. And when I factor out negative 2 from here, I'm going to be left with 3. Negative 3. So if you look here, whatsoever is in this parentheses has to be the same term in the other parentheses. Sir, why? Because at some point in time, I'll have to factor it out. So when I factor it out, whatever is left is going to form my other parentheses. Watch me. I factor it out. So watch your screen. This I'm taking out. This I'm taking out. What do I have left? Say x.
Insert the x.
Minus 2.
Very good. I'm going to have
minus
the x
2.
that is left. I'm going to have the x that is left. What is wrong with this thing here now? I don't like when this thing give me a problem, you know.
Sir, and because you already factored out the other one, you only have the negative 2.
Very good. And because I'm going to do the other one very nice, I'm only going to be having the -2 there because the other one is going to go. The other one is going to go. Very nice. Oh, no, I know what is happening. Okay, now I know what is happening. I was trying to color code it, but I just recognize what is happening. I use a software to type my notes that I'm presenting to you. So that's what is the problem. All right. Okay. And then now I'm going to end up with x minus 2 times x minus 3. So very good for those who came out of the ballpark with it first hand. Very nice. What is going to happen now, guys, is if I have x minus 2 times x minus 3, and somebody else has x minus 3 times x minus 2, it is the same thing. 3 times 2 is 6, and 2 times 3 is 6. So look at what I'm going to be doing. Remember the original, we don't start the question, we just recognize that it's indeterminate. Let me just say something now, please, guys, because every semester I have the same problem. When you're evaluating your limits, and you get 0 over 0, you notice I never say 0, because 0 is different from 0 over 0. When you get 0 for your limits, it is telling you something different from 0 over 0.
Yes, sir, because I cannot divide by 0.
Very nice. Very nice. So when you have 0 over 0, it is telling you something very specific, that the function is indeterminate. The question is indeterminate. Indeterminate, we can't determine what one. Something is preventing the true limit of the function from coming out. So I'm still going to write indeterminate on the paper, but I must do something in order to get rid of that something. I have to take off the filter of TikTok so you can see the true something, the true being. So what it is that I'm going to take off is one of 3 things. It's going to be either a factorization, a simplification, or a rationalization. So I'm going to do one of 3 small steps: a factorization, a simplification, or a rationalization. Now, when I perform one of those 3 procedures, it means that I'll be able to isolate what is causing the problem and remove it. I will isolate what is causing the problem and I will remove it. All right? Watch me. So now I'm going to have x minus 3 x minus 3 times x minus 2 over x minus 3. You recognize that the x minus 3s, they can cancel out? Good. So I'm only now left with x minus 2. So when I rewrite my question, I'm going to have x minus, the limit as x tends to 3 of x minus 2. Then I go ahead and substitute my, coming to you, Kenneth, substitute my value 3 because I'm still using a calculations approach. And 3 minus 2 is going to give me 1. So the limit of that function tends to 1. Yes, Kenneth, go ahead, please.
Never mind, sir. I just realized what I was doing. Never mind.
Okay. And that's it. That's the limit of the function. That's how we do it. Any questions?
Not immediately right now, sir. We're going to need to go over it again with another question just to make sure.
And there goes the question. Who is that speaking?
Tika.
Sure. Go back to the question. Take it down. Right. Upward factorization down.
Okay, right here, sir. Ashanti, right there?
Yes, sir.
Good job. All right. So I'm gonna small it up a little bit so that those of you who want to get going with this question. See another question here. The limit as x tends to 4 of x plus 1 over x squared minus 1. I'm giving you 5 minutes to figure that one out and to work through the question for me, please. 5 minutes. As a matter of fact, 4 minutes. 4 minutes.
Sir, before you step away,
Yeah.
you can scroll up back. Let me say the question for the first one. Scroll down a little bit more. Yep.
That's it?
Yes, sir.
How we stay? How we stay? How we stay?
Sir, I'm confused.
So I'm kind of finished, but
all right,
we're
sir.
supposed to factorize.
Now hold on, somebody speaking. Go ahead.
I'm saying I'm confused because I don't get 0 over 0, I only get 0.3. Should I still factorize that?
Okay.
All right, sir. We do the application of the algebraic thing on me test with the intermediate. Yeah, hear me?
Yeah, man, talk it to you, man.
Yeah, me test for the intermediate, so I'm gonna get 0
The
over 0.
indeterminate. Say indeterminate.
Repeat?
Say indeterminate.
Indeterminate, yeah.
Right.
So I'm gonna get 0 over 0. So my answer is 1 over 3.
Thank you very much.
Same answer here, sir.
Very good.
So I
And
have to say,
yes, man. But you see, only when you can get indeterminate. When it is what?
0 over 0.
0 over 0.
0 over 0, yeah. So the first person to hit the ball out of the ballpark was Justin. Very good, Justin. I didn't want to tell you that you are right, but very good, Justin. Ashantia, yes, you got it. Yes, Logan, you didn't get 0 over 0. So what? Tell me what you get.
No, my kids.
I don't want to hear no excuse.
But I thought it was 0
You
to 0, but I
are
didn't get any
doubting
0
yourself.
or 0. So I was
You are
confused,
doubting
like,
yourself.
should I get 0? I mean, calculate, I did not get 0 to 0. So I was asking anyone to get 0 to 0.
You're doubting yourself. Tice, very good.
I got 5 over 50 and I cancel it 1 over 3, but I don't know. I don't get 0 to 0. So it's not like indeterminate or anything like that.
Yeah, so it is not indeterminate, it's just not indeterminate.
Oh,
If it's not indeterminate, it's just not indeterminate. Go
I
ahead,
thought you're
please.
going to give us another example of it.
Don't worry about it. Anything about it, you see, that's a problem. I'm not teaching you to be stereotypical. I'm teaching you so that you can be able to decipher on your own which is which. And that's why I did what I did. Because most of you were expecting to get 0 over 0.
So it would be surprised how many times I calculate.
No, don't worry about it.
sir, what I did is factorize the denominator.
Well, we don't reach your, but yeah, you're right. Yeah. We don't reach your say yet, you know, but yeah, very good, Ashanti. I'm proud of that. Alan, I want you to talk to teacher. Talk to me. Lecarno? Lecarno gone.
Sir?
Talk to me, Papa. Me hearing you now. Talk to me. Tell me how you got that for the answer. And I'm saying to you, tell me how you got that for the answer. I'm only asking you no because I said that to send it to everybody. Those who send me this stuff privately, I will respond to them privately. But because you sent it in your group, I want you to tell me no. How you got that for your answer? I cannot figure what you did. But you tell me how you got that.
That's why I asked her if it's only when you get an indeterminate, you're supposed to factorize.
But you're not going to know if you get an indeterminate, so you have to do the factorization first. Talk truth.
Yes, I realize that after, so
okay.
Example.
All right, fair enough. I'll come back to you, Ashantio. All right. I don't know how else to do this, guys. Forgive me. My teaching style is to use varying examples to bring across my point. So just work with me. I'm going to say to you, it's whenever you get a question on limits, and you get something that is of the a fractional form. When you get something of a fractional form, always think about it being indeterminate. The first thing that should come to your mind when you see something of a fractional form. So what do you mean by fractional form? Numerator, denominator. As in this example, x plus 1 is in the numerator, and x squared minus 1 is in the numerator. Whenever you have something of that nature, always think indeterminate. What you're going to be doing is substitute the value. You're going to assume that the answer is that. You're going to substitute it into the function. When you substitute into the function, if you get 0 over 0, then it's indeterminate. If you don't get 0 over 0, it means that it is not indeterminate, and the answer that you get is going to be the final answer. Am I clear right there?
Yes, sir.
All right.
Yes, sir.
All right. All right. Students, make sure that when I ask if you're understanding, you're speaking the truth. Now, Ashantia said she factorized the denominator. That's advanced thinking. Advanced thinking. Because at this point in time, we really never needed to do the what do you call it? The factorization here. But she did it and it came out. So here what I wrote. So since you did not get 0 over 0, it suggests that the question is not indeterminate. Therefore, you don't need to factorize. You just simply, no need to factorize or simplify or rationalize. The question done. So what Ashanti did here was just advanced thinking. But if you did it, you would still get the full marks. Am I clear right there, guys?
Yes, sir.
Yes, sir.
Come on.
Yes, sir.
So Ashanti, because she's understanding what to do, she went ahead and did her factorization. Boom, she get full marks. But somebody else, on the other hand, now decides, you know what, I'm going to test for indeterminate form first by using the algebraic approach and substitute my something into my something. And I get 1 over 3. Blow, sir, it's not indeterminate. So Ashanti did advanced stuff. And she get the answer. It's like she driving a fast car, a BMW. She get to the party earlier, but you driving your Nissan. You'll get to the party. You may not get there as quickly as she did, but you can get there too. So this is what it is. Are you clear with what I'm talking about, guys?
Sure, the analogy there, right, sir?
Say it again.
You're sure that analogy is correct?
Why?
Because if Ashanti used the factorization, wouldn't she take a longer time on the question?
Oh, so you're saying she drive the BMW then?
Exactly, sir. Flip.
You see, bad man, you know, I try you want to drive the BMW. Me say, it's Ashanti, same stay. Anyhow, I get your point. But you get my point, though, too, right? All right.
Yes, sir.
Now I want you to try this. I now want you to try this. But, sir, under the same question I give you, is it the same question?
No, sir.
Yes, sir, but the limit weight approach to change. That's a negative one.
So is it the same question?
No, it's not the same question.
No, it's not the same question. The function is the same, but the question isn't. All right. Try that one for me now and tell me what to get. Guys, you have to work with me now because we're moving, you know. I'm developing.
Sir,
no more
I just want to know, is that a negative 1?
Yes,
X
my love.
to Y is negative 1?
Yes, my love. Yes, 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 it
Okay.
is.
Just want to make sure.
I'm gonna see that we don't say 0.
From me sitting, I say 0?
Yes, sir.
How you know that? Because me can't look on it and tell you. Oh, you can't tell me that.
Negative 1 plus 1 and negative 1. So it is, sir.
But negative 1 squared and a negative 1.
No, sir, positive
No,
one.
sir.
Ah, good job, my pops. Good job. Good job. Yeah. But I don't want you to just Kenneth, just tell me say, sorry, zero. You have to work it out and
Sorry,
show me that you
zero
get the
over
zero
zero.
over zero.
Yes,
Right.
sir.
0 over 0. Everybody got the 0 over 0?
Yes,
Yes,
sir.
sir.
Yes, sir.
Seven,
All
work
right.
it out now.
What is that about Logan?
You couldn't let me just work it out.
I
We
know it's
just see
taking too long.
visual.
You're taking too long. I can't wait when you're taking too long. Christmas
Alright,
game coming
sir,
up.
go on.
Yeah, man. Get for work fast, man. Come on. Quick, quick. We can pass. All right. Now, so those of you who got your 0 over 0 for it to be indeterminate, I want you now to do the other part of it. You know, when it is indeterminate, there are several things to check for. One, a factorization, a rationalization, or a simplification. Now, the mere fact that I don't teach you simplification and rationalization, you know, so the question is going to be on factorization. You get that?
Yes, sir.
All right. Well, good eating.
I can contest. Still there? Marsha, you're back. I'm not hearing Marsha. Marsha, can I hear both? All right, so we're gonna give her a minute to connect. We're not hearing you. Maybe you want to connect audio and then rejoin. We'll take you when you come back. Is there anybody else that would like to go in the meantime? Hi. Hi. Are you here to hear me? Yes, I am. I need to do that one role. I just wanna I'm feeling this with you, trust me. But there is there's nothing bad to say about this person. He's in the classroom with him. He ensured that who understand.
Sir, mute your mic, sir.
Oh, sorry about that, Papa. Thank you. Alrighty, I'm seeing responses, and I see Ashanti say to everyone -1/2. Logan is questioning how -1/2. Tice, I see you. Raheem, I also see you. Logan, you are losing confidence.
Sir, I need to know the answer. Because I
No,
just
no, I'm not telling you the answer. Lecarno is the second time I'm making this mistake, and I know what it is that you did, Lecarno. It's the second time I make the mistake. You did it for the first one, and I was asking you how you got it, and then I'm seeing something again. So I need to talk to you. I need to talk to you.
So is -2 the answer?
No.
Okay.
All right. You guys are mean. All right. I didn't do this question, so let me do it now. All right, so
Sir,
go ahead. You're saying what?
Sir, the answer x -1.
I don't know. I'm not sure yet. So I'm gonna have -1 + 1 over -1 squared minus 1. -1 + 1 is going to be, oh, that's 0. And -1 squared is a +1, +1 minus 1, 0. Okay, so I'm going to say indeterminate. So you have to write that in the exam? Yes. Let them know that you know that's indeterminate. So the question finished? No. You have to either rationalize, simplify, or factorize. So let's go. I'm going to factorize. I'm going to say the limit. Okay, so I'm going to recognize that x minus 1, x squared minus 1 is the difference of squares, which is x plus 1 times x minus 1. Do you all agree with that?
Yes, sir.
Yes, sir.
Yes, sir.
So rewriting you have x plus 1, sorry, you have to write that, the limit as x tends to -1 of x plus 1. I'm rewriting now to give me x plus 1 times x minus 1. That cancels that. Now it reduces the question to the limit as x tends to -1 of 1 over x minus 1. Lecarno, you see the mistake now?
Yes, sir.
Tell me what your mistake is.
We'll take away the substitute the plus 1 instead of the minus.
That's not your mistake, sir. You did it up top. Let me show you what it is that you've done. When you retract here, you cancel this, and you cancel that, and this is what you wrote. The limit as x tends to 4 of x minus 1. And then you do the substitution to say 4 minus 1, and you say it's 3. That's why you got the 3 for that one up top. Remember you got 3?
Yes, sir.
Let me show you what it is that you do down here. So now, you did that same calculation right here, so, and instead of putting x1 over x minus 1, you just put x minus 1. And when you put a -1, minus 1, you get -2. You have to remember, Pops,
sir,
that x plus 1 into x plus 1 goes 1 times. And this here goes 1 time. So what you're left with is a fraction with a 1 in the numerator. You follow me?
Sir, quick question.
I'm coming to you. Lecarno, talk to me now, Papa.
Yes, sir.
You recognize it's the second time now you left off the numerator?
Yes, sir.
And when you did it the first time, I knew what it is that you did. So it brings across my point, students. And I'm going to forever say this. You're getting tired of me. No problem. You can get a new teacher for calculus 2. You must speak in class. If you don't speak in class, I won't know what it is that you're doing. If you don't contribute and post your answers, I won't be able to interpret your answers to know that you're following. And what is going to happen to you is that you're going to have your misconceptions. You're going to leave the class with the misconceptions. And you're going to hold on to the misconceptions like gospel. And you're going to go into the exam and write those misconceptions. Speak, speak, speak. Logan, you don't have anything to say again?
Yeah, I have something to say. I just wait until you finish.
No, I said
Just
go ahead.
Okay. So even though you cancel up the top, you still put back the 1?
Yes, man.
I never
Yes.
did. I just
That's my
put the
question.
-2 because I thought if I cancel up the top, I cancel on the bottom, it just leave with the x minus 1. I just plug it here, get the answer. I don't know,
All
you
right.
must still put back the 1 up the top.
All right. Sorry, somebody was saying that that's what they did, just the same thing like that Logan did. Who was that?
So I was saying
Yes.
that thing that I saw.
Kahim, sir.
Kahim. So you're thinking the same thing, Kahim?
Yes, sir, because originally I thought the answer was x minus 1.
All right. Lecarno, unmute for me, please, Papa. Hello?
Yes. Yes, sir.
You recognize that you were not alone?
Yes, sir.
And this is one of the things that irks me in class. Sometimes we have our questions and we don't answer it. Ask it. And we're depending on somebody to ask a question. And this is how you learn from each other. Because I recognize the same error that Lecarno did on 2 occasions. I spoke about it. Kahim, Did you tell me that in the first instance what it is that you did? Yes or no?
No, sir.
Hold on. Logan, did you tell me that's what it is that you did for the first one?
Yes, I did.
No, man, you never tell me because I'd correct it.
I didn't make the same mistake. It was a different thing. You only told me to have more correct, but I have the answer.
No, man, hold on. Did you get negative a half?
No, I got -2. I never know that I must, each time I cancel
Fair
the
enough.
top and the bottom,
Fair
I
enough.
must still put back the 1.
Watch me now, love you. Watch me, work with me. This one up here, did you get +3 for the answer? You got a 1/3.
1/3.
Okay. So why would you have gotten a question right up here, but go down here and do foolishness?
Because I didn't do the fraction part, sir.
But hold
I
up.
just,
But
yeah.
why would you correctly do the fraction part up here and then go down here and do foolishness? That's what I'm asking.
I don't know.
All right. So guys, again, now this is showing us that we need to be consistent. So if you do it up here, so and get it right. Just do this down here,
Because,
so.
oh yeah, I remember now. It's because that when I plug it in, I put 15, no, 5/50, and then I cancel it. I remember what I did. I said 4 + 1 and 4 square minus 1. So I get 5/50, and then I cancel to get 1/3. So now I'm doing the fraction part and got confused.
No, but Logan, 5/15 is the same fraction to you, no, my love.
Yeah, but I never know. I say anytime I cancel the top and the
5
bottom,
over
the 1
5
was
over
still
15.
made.
5/15, Logan, are the same fraction, my love. Trust me.
Okay.
Ouch. Yeah, man, are the same fraction. All right. Let me just pause and say something, please. I'll pause and say something. I don't know where you guys are mathematically. What I'm sensing is a lack of confidence from some of you, not just Logan, from some of you. There's a level of you not wanting to unmute to talk to me. You're hesitating. And that can't work. There is no way you're going to be the success that you want to be if you do that. No way. I want you to develop a level of confidence. When we're in class, ask me the question then. Drop it in the chat. I will look at the chat. And I will address it. Don't come to class and leave class with any uncertainty. Because trust me, many of you don't have any help at home to help you with the calculus 1. Ask me, I'm here to help. All right. Here goes question 4. I want you to try question 4 for me, please.
Sir.
Question 4. Yes, sir.
I don't mean to disturb you, sir, but we have a presentation now in the next class.
Oh, Rockstone, no,
So I have to
sorry,
leave.
forgive me. No. I never recognized it's 8 minutes past 7. I apologize. Have a wonderful
So
evening.
just wait. So we just write the question, then we can do it for homework.
Yeah, man, write the question, please. Listen to me. When you must tell me when at 7 o'clock, you know, me never know. Me did ready for going. A 4th game, me ready for going, you know. Take the question off for me, please, and do that for next class. No, man, sure.
Work it already, please, sir.
Rockstone, but guess what? No, I have another class. Oh, no, hurry and take it up because I have a 7 o'clock class. I never recognize. Quick and fast because I need to go join them. My goodness gracious.
All right, sir. All the best.
Big up yourself.
Okay, sir.
Yeah, man. Cool. Yeah, man.